So on the last lesson, we finished creating the body of our cell beam, actually of a beam cell, sorry. And now we will start the loading the secondary beams with the load which is equal to our task. Each of us have their own task of the loading, so I will took my own load, and it is equal to it is equal to 21 kilonewton per square meter. 21 kilonewton. So what I need to do firstly? So I knew that there are 21 kilonewton for 1 square meter. Now I need to find total square of the beam cell, балочная клетка. So total square of it. I need to multiply the length to the width. 12 multiply 80. 260 square meters. So now I multiply to 21 kilonewton. So I found 4,536 kilonewton. This is my total load for all beams. And now I need to know how many load will be act for per meter, на погонный метр, per meter. So to find the total length, I will select only my secondary beams because we'll load only them. Now I will multiply 20 meters to 1, 2, 3, 4, 5, 6, 7, 8, 80. 12 to 80. $252. So now I found that for 1 per meter there will be 18 kilonewton. 18 kilonewton for 1 square meter. So need I repeat all I said in Russian, how I find it?
Yes, please.
Вот у нас с вами балочная клетка. Мы знаем нагрузку на 1 квадратный метр этой балочной клетки. Она дана нам по заданию. У каждого своя. У меня это 21 килонewton. Нагрузка передается равномерно через настил металлический на балки настила. То есть не на главную балку, а на балки настила. Соответственно, балки настила — это линейные элементы, стержни. На стержень мы не можем задать нагрузку, которая рассчитана на 1 квадратный метр. Правильно? То есть это поверхностная нагрузка на пластина, у нас стержни. Так вот, чтобы задать нагрузку на стержень и понять, а сколько же тогда на стержень нужно задавать, нужно первое, что сделать, это найти общую площадь, на которую действует вся наша нагрузка. Общая площадь равна 12 метров умножить на 18 метров, то есть 252 квадратных метра. Это общая площадь. Теперь 252 квадратных метра я умножаю на 21 килограмм. Получаю 5292 килограмма. Вот моя нагрузка, которая действует... прошу прощения, килоньютона. Это не килограмма, далеко не килограмма. То есть это 55, получается, сколько? 500 тонн. 500 тонн действует нагрузка на вот эту всю балочную клетку, на равномерно распределенную балочную клетку. Теперь нужно посчитать, а сколько же действует на одну балку, а точнее на ее один погонный метр. Для этого всю нагрузку 5292 килоньютона нужно разделить на длину всех балок. Длину всех балок, чтобы найти, нужно просуммировать длину каждой балки. Для этого нам необходимо измерить длину одной балки 6 метров. Таких балок у нас 18. Здесь 6, 18, то есть 36 на 18. Итого мы получаем... Сколько будет? Не, 36 не на 18 уже. 36 на 6. Да? 36 балок длиной 6 метров. Получается 6, 180, 6 и 6, 36, 216.
216? Да.
216. Значит, мы должны 5292 разделить на 216 метров. Получаем 24,5 килоньютона на погонный метр балки. Понятно?
Угу.
Все ли поняли?
Можете
Да.
повторить это? Можете повторить из-за зависания, не услышал?
Не услышали, сколько равно, или не услышали все, что я сказал?
Сколько равно этот из-за зависания?
Общую нагрузку я разделил на 216. Итого получил 24,5 килоньютона на один погонный метр балки.
Спасибо.
Okay, so I have already found the total load for 1 per meter of the secondary beam. Now I need to select the beams, secondary beams. Select them all. Press button edit load cases. Load case, okay, load number 1. It will be live temporary load. Then I will choose the load on bars. And we'll choose the second type. And here I will write 24.5. Okay, so my load is added. Now I will press restore model. Then and select all. What I need to do next? First of all, I need add to the main beam the special characteristics. What type of them I will show you now. This is our main beams. Main beams we should add like edit like a structural elements. So we generated one. We will select other one, second one, and the third one. Now we will select the two parts of one main beam. After selecting, we'll add the deflection fixities. So we need to say to the program that the beam will have deflection under the load from the secondary beams, and we'll make the create ends of structural element. We added it. Also we will make with this element and with third main beam. Restore models. Now we will add it to the secondary beams. We'll select secondary beams by the stiffness. Make the fragmentation of them. We'll select all of them. Pick the option bars, deflection fixed, and we'll change this position, not create ends of structural elements, create on each node. Because we need in each node there should be deflection. Because this one part, one leg of the beam is supported by the main beam, and this end of the secondary beam supported by the main beam on each node. So now each of these beam will be deflected by the load, each beam separated. Restore models. Also, what we can do, we can add the fixing to these secondary beams. What does it mean, fixing? Fixing will tell us that the connection between beam and secondary beam is not rigid connection. With the same processes, we'll select secondary beams. We'll go to the bars and we will hingers, define as hingers, and we will add U and Y, U and Y, from two parts, from one part of the secondary beam and from another part of the secondary beam. Now we see the hingers. And the same position will add to the ends of the secondary beam. Secondary beam is also have not the rigid connection with the column. And here is opposite part. Okay. Now we'll apply hingers to our vertical bracing elements. Okay, we will pack our model, save our calculation, and try make the analyze. We'll press button analyze. We'll go to the steel. According to the first limit state, we will see that there are no problem. According to the second limit state, we see some problems with the secondary beams, if I'm not mistaken. I will use the button information about nodes. We'll add one of them, and I want to see what is the program assign me to choose. So I used the I-beam with number 33, and program tell me that I need use I-beam number 36. But this is the first one. What I need to do, it is to select all of the secondary beams. Now I see the overbuff limit of stability, serviceability, and I need to reduce it as less as I can, but it should be less than 100. Now I can go to the sections, and so I see that it is a problem for all of them. They all require beam 36, I-36. So I will go back to my model. We'll go to the material properties. We'll find this beam, press the button edit, and we'll choose 36. We'll make the pack of model, and again I will analyze this scheme. Now I saw that there are no problem with the beams. Here is some problem with the bracing elements. Let's see what they want. Implementation. So the program tells us that we need to change the section from the vertical bracing from 75 to 100, so equal angle 100. We'll go back to the material properties, angle 75. I will edit it, use 100, and thickness 6.5. I will back to the model and make the analyze it. Okay. Oh, what about local buckling? What is the problem with the main beam? Okay, let's try select main beam. If there are some problem with it. So program tell me that there are no reason to use such a big section for the main beam. Maybe it will enough to use for flange 360 to 16 thickness, and for web, I'm sorry, I think This is my son is playing with the lighting. One moment. Okay. Again, all right. Sorry. So, okay, let's try to change the thickness and the size of the built-up section for main beam. So it's required 360 and 450. Okay. Okay, 360. 450. Okay, restore model. Let's see what will be if we'll choose the last section for the main beam. Now it doesn't work according to the third limit states. You see that it's not enough in 6 time. The same problem with the second limit state, but here is no problem. Okay, it's actually not so good. So we'll go back. Oh, I can go back because I press button save the model. Okay, let's check, can I do it or not? I think no. Okay, so I need to change again and apply the first sections which was before. I tried to change it. And so in that case it will be alright because first and second limit states is on the good positions. They are not more than 100. It means that it is enough to ensure the guarantee that it will be stable and stability of all beam cell is guaranteed. Ensure it. Who remember how many millimeters was this section of flange? Nobody does this. Okay, if nobody does, so I need to use the picture number 50. 1750 to 12. Yes. 1750. Okay. here 550 to 25. Let's check what it will be. Okay, that's all right. That's all. Now we can check what type of section did I apply for the secondary beam according to the first and the second example of handmade calculation. 24. Also, we need to we'll be able to create the second one, because the first of our beam cell was have this scheme, principal scheme, and maybe on the next lesson we'll try to design this construction scheme, and we'll see what type of secondary beams and main beams will be here. What can I say? Here is 33 and it was enough. So what can you say about handmade calculation and program calculation, in your opinion? What main features of handmade and how you can distinguish it from the program calculation?
In handmade calculations, we can make some mistakes, which are very rude for construction industry. In computer or in programs, we can calculate all of them are very nice.
And what about section? So we,
or short form, this is convenient.
The computer program is more convenient?
Yes.
And what about section?
No. I say convenient.
Convenient?
Yes.
Convenient, maybe. Удобно.
Sorry.
Yes. We understood convenient. Oh, okay. But what about the size of section? What do you how we can analyze it? The handmade section was one and the program section was other. How you can describe this position?
What?
So during the handmade calculation, look at the my guidance, study guidance. I applied the I-beam 33 and it was enough. You see that applied section is enough according to the durability and the deflection. But according to the computer program, this section 33 wasn't enough. And I was able to use other section 36 what does it mean to you? How you can describe why it was so? And maybe I need to use here 33 section, number 33. Maybe I will ask it in Russian.
Maybe in program we have 33 or what?
We're not sure.
I think so.
Who else? Maybe somebody can tell us why there was other section.
Maybe we could do a mistake.
Why there are some differences between one calculation and other calculation? What do you think?
Maybe we can make mistakes when we calculate without program.
I don't think so that there are some mistakes, because during most of work I had done, so, and my experience tell me that program calculation make and apply some sections more than handmade calculation, because there are added some safety coefficients which not permit sometimes sections with a less size. According to handmade calculation, it was enough 33, but according to the program calculation, there wasn't enough. But there are the same length of the secondary beams, the same load for them, but in this case, it's not enough. It means that sometimes program help us not to do mistake and apply the sections with the more size and thicknesses. And so it will save us during, for example, will be some overloading. So, for example, I was calculating 21 kilonewtons, and for some reasons it was loaded by the 25, for example, kilonewtons. And so beams applied according to the handmade calculation will be not ready to apply that load. And there will be some bucklings or deformations, or maybe just some places will give the failure and crashing. Okay, just my opinion according to many future studies or past studies. Okay, that's all. So if you maybe you have questions or not, there are only 1 minute.
Now we have it.
You don't have? Okay. So thank you very much.
Yes.
Today we had 3 lessons, 3 difficult lessons. So every Monday is difficult for us actually, but I think the next days will be less difficult, and we will have more funny time for spend it with our friends. Okay, by speaking in English, maybe by watching movies and so on.
Yes.
Okay, thank you very much. Goodbye.
We hope
See
so.
you tomorrow.
Okay. Goodbye.
Goodbye.
Okay.
Goodbye.